last set of homeworks. We'll take some questions from homework here in a minute, absolutely. But I'd like to start with some observations before we get going too far there. Where did that go? Sorry, I want to have this open. I don't know where it went to. Oh, there it is. All right. So in the previous homework, I think we had added 10. But I had been seeing this even before this. So for example, if we had a problem like this, I see some people writing like not factorable as a solution, which is not appropriate here. If there was no equals 0 at the end of this and we're asking you to factor, sure. On this problem, the directions would have been to solve because it equals 0. Every quadratic is solvable for us. We've done enough between the quadratic formula and the reverse order of operations and factoring that every single thing that we encounter should be something we can come up with an answer for. So in this case, if this is not factorable, we would want to use the quadratic formula. I also saw in some cases like things like this, people writing no solution. Again, this is a quadratic. Every quadratic is solvable. None of them have no solution. In this case, since it's an equation that's in vertex form, the easiest way to deal with this would be to use the reverse order of operations to solve this. Now, you could also expand this out so that it was in standard form and then try factoring or the quadratic formula. You could also do that, and that would be appropriate as well. I think that's a lot more work, but it's not inappropriate. So just to kind of summarize here as far as solving goes. So if you have something in standard form, the first thing you'd want to do is get it equal to 0. So you might have to add things to both sides or subtract things from both sides to get all the stuff on one side of the equation. And then you can use factoring sometimes, right? Because we know that not every quadratic is factorable for us, but some of them are. Or you could use the quadratic formula. And the quadratic formula works all the time. It always works. And the last thing that we could do is you could, for some of these standard forms, it's pretty easy to think of it as a vertex form. And in those cases, you could use the reverse order of operations as well. So an example of a situation where it's going to be easy to do that would be something like x squared plus 5. When there's just x squareds and there's no x term, you can think of that as standard form, or you could think of that as vertex form, and you could use the reverse order of operations on that. And that's probably the easiest way to attack a problem that looks like that. So if we have something that's in vertex form, the best thing we'd want to do is to use reverse order of operations, or you could write it in standard form and then use one of your standard form methods. And I'm not going to rewrite those because we just had them above. And then the last situation we had was a quadratic and intercept form. Now, I want to point out something that I probably should have a moment ago. Notice in vertex form that we don't require that to be equal to 0. It doesn't matter as long as the only x's I have are inside that parenthesis with the squared on it. It doesn't matter what else is equal to, what else is over there, as long as there's no x's, it's fine. So that doesn't really require being equal to 0. Intercept form does, though. So if the intercept form is equal to 0, then we can just use the 0 product property to solve this directly. Or you could FOIL things out to write it as a standard form and then use a standard form method. Not recommended there because the 0 product property makes things so easy. If that intercept form is not equal to 0, we can't make it equal to 0 and still keep it in intercept form. So here, in that case, you'd be stuck foiling things out to get it into standard form and then using a standard form method. So I just wanted to start here by kind of rehashing what are the, what are our solving methods, when to use what method, as I think that that's still something that looked like we're maybe a little shaky on. And that's okay. Again, we'll continue to kind of do work on that skill as the semester or as this chapter rolls on. We still have 2 more skills to talk about in this chapter, and we'll be starting one of those new skills today. They're nowhere near as time-consuming and as lengthy as in depth as the simplifying and solving skills have been. So it won't be that much longer in this chapter. But we still do have 2 more skills to kind of talk about. Okay. So let's take a moment and take some questions from the previous homework, or maybe even some questions in general. So if you have a homework question and you'd like to talk about it, you can type that into the chat and I'll do a couple. And if you don't, that's okay. You don't have to do anything. So I'll wait a minute to see if anybody has anything. Again, the homework we checked over the weekend was homework 10. All right, fair enough. So nothing's come through. It doesn't mean you can't ask about something later on, but since nothing's kind of come through, we'll just kind of move on. Oh, you think we did homework 9? That would make sense. Homework 10 is what I was assigning today. Yes, I misspoke. Thank you. Again, these are the sorts of things where if I'm saying something that's just like wrong and kind of confusing, and I'm not realizing it, feel free to like chime in and be like, Mr. Kulik, I think you meant number 9 or homework 9. And that's totally okay to do. You can do it in the chat. It's fine, totally fine. But if you'd like to do it aloud as well, that's okay also. Okay, so we do have some questions for homework 9, which makes sense if you're looking at homework 10, that you're like, I don't know how to do any of this. So it would have been really confusing. So 7 and 9, I see. Okay. So 7 is in standard form. So I could do this by factoring, or I can use the quadratic formula. Now, if I look at the numbers involved with 7, to factor this, I'd need to find two numbers that multiply to give me 70 times negative 104 and add to give me 11. 70 times 104 is a big stinking number, and it's going to take me a while to kind of sift through all the possibilities to figure out the two numbers that add to give me 11. I'm not really interested in doing that. I would use the quadratic formula in this case because although I have to do a little bit of number crunching, it's like the same amount of work whether the numbers are big or small to some extent. So that's what I would do here. So the quadratic formula again is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And to do this, I'm going to do 11 squared minus 4 times 70 times negative 104. So I'm going to do that part that's underneath the square root, and then I'm going to take the square root of that. So that's 171. So then I can break that up into two problems. One is an addition problem, and the other is a subtraction problem because of the plus or minus is why I'm breaking it up. So that becomes 160 over 140, which is the same as like 16 over 14 or 8 over 7. And that would be negative 182 over 140. And that one, I'm not sure I'm confident I'm going to reduce it in my head at 8:12 in the morning. So I'll just use my calculator to do the reducing for me. So I'll just type it in as a division problem and then hit math and then choose the fraction command. So that's negative 13 over 10. So those would be my two answers for number 7. Joe, does that feel good?
Yes, thank you.
Yep. And then we also wanted to look at 9, right? So looking at number 9, this is again in standard form, so I would start by thinking about factoring or using the quadratic formula. Now this one is a good candidate for factoring because the leading coefficient is 1, so I could potentially be able to use a shortcut to do this. The problem is there aren't two numbers that multiply to give me 29 and add to give me negative 10. 29 is a prime number, so just 1 and 29 are the only two numbers that multiply to get there. So since factoring definitely isn't going to work, I'm going to do the quadratic formula again. I have no choice in this matter. The previous one actually would have factored, but the factoring looked like it was going to be pretty tough to find the two numbers that I needed, so I just bypassed that altogether. So I'll do the same thing here. So I'll start by doing the part underneath the square root. Remember, we called that part the discriminant, was the name we gave for that. So when I do that, I get negative 16. So a couple of things to remember here with that is that when we take the square root of a negative, that's going to make an I. And then we have the square root of positive 16. So putting the I out front gets rid of the negative sign underneath. And the square root of 16 we can do, that's just 4. So I can think about these as two separate fractions now. Oops. It's supposed to be a 2. So 10 over 2 is 5. And 4i over 2 is 2i. And we can't combine an imaginary and a real thing together, so we just have to leave it with the plus or minus there. And that's going to be our final answer. And again, on both of these are both ones that you could check with your program on your calculator that we made. Since they're all in standard form, or both 7 and 9 were in standard form, you could have run those on the program on your calculator to check these answers as well, and they would have matched right up. The directions here was saying you must show work, so just like writing the answer down was not appropriate here. But certainly there's no reason why you couldn't use the program after you'd solved to kind of check your own work there. Okay. Anybody else that is looking for questions here? This is from homework 9, by the way, not 10, as I said earlier. I did an oops-a-daisy, but thank you guys for pointing that out and catching me. That helps.
It's not about the work.
Okay.
But I think there might be something wrong with your microphone.
Okay.
Because every once in a while it just makes like a really loud noise.
Interesting. Okay.
I might be the only person hearing that though.
Okay. Interesting. Yeah, I don't know that I know exactly what to do to check on that at this moment. But I will make a note of that and look into it for next time so that you aren't getting your eardrums blown out when when the recording here or the call randomly makes a really loud noise on you. Okay. So let's start the new stuff today then. So today we're going to start talking about graphing. And we'll spend a day or two talking about graphing. So the graph of a quadratic looks like, or is called a parabola. And what a parabola looks like is basically kind of like a U that either opens up or it opens down. So it's going to be easy for us to tell whether it opens up or opens down, because all we have to do is look at the sign of the A coefficient. So if A is positive, the parabola will open up, and if A is negative, it opens down. And when I talk about A, I'm talking about the A's from, say, a standard form, or the A from a vertex form, or the A from form. The sign of A, regardless of which form we're talking about, is what controls whether the parabola will open up or open down. So when we talk about parabolas, there's a few key features that we're going to be interested in. So let's say we have the parabola here. So the first key feature is called the vertex. That's either the lowest point on a parabola that opens up, or the highest point on a parabola that opens down. The next is called the Axis of Symmetry. So the Axis of Symmetry is a vertical line that divides the parabola into like two mirror images. So like splits it in half. All parabolas have an axis of symmetry, and they always go through the vertex. There's X-Intercepts, and that's just where the graph crosses the x-axis. Worth noting here that we don't always have x-intercepts. So for example, if you have a parabola that opens up, whose vertex is above the x-axis, it won't have any x-intercepts, right? Because it just continues going up. If the x-axis is below it, there's no opportunity for it to cross. And then the last key feature there is the Y-intercept. And the Y-intercept is just where the graph crosses the y-axis. And that will always exist. Are there any questions about what these four key features are, or if you were to look at a picture, how to identify them? Okay. So let's talk about how we find them algebraically. So we'll start with the Y-intercept. Because it's the easiest one. Because basically all we need to do is plug 0 in for x, and then simplify. So for example, if I have the quadratic and standard form 2x squared plus 5x plus 6, if I plug 0 in for x, 0 squared is 0, 2 times 0 is 0, 5 times 0 is 0, 0 plus 0 is 0, and 0 plus 6 is 6. So my y-intercept is 0, 6. If we had our quadratic was in intercept form, nothing really changes. We just plug 0 in for x. 5 plus 0 is 5. 0 minus 3 is negative 3. Negative 3 times 5 is negative 15. Negative 15 times negative 3 is positive 45. So our y-intercept is 0, 45. And if we had vertex form, again, same thing, we'll plug 0 in for x. So 0 plus 4 is 4, and 4 squared is 16. 1/2 of 16 is 8, and 8 minus 3 is 5. So we have the point 0, 5 is the y-intercept. So that should all feel pretty comfortable, right? You're just basically plugging 0 in for x and then evaluating what you have left, and that's how we get our y-intercept. Any questions on how we did those? Okay. Next up was part C, was the X-intercepts. And to do this, we're going to plug 0 in for y, and then solve for x. So for example, let's say that we had this standard form. So we could plug 0 in for y. And now this becomes kind of like a problem from homework 9, right? So to solve this, I could either use the quadratic formula or I could factor this. Since the leading coefficient is 1, I'm going to try to factor it, because if it factors, it should be pretty easy to do that. The two numbers that multiply to give me 12 and add to give me 8 are 6 and 2. So I can solve this. And if I subtract 6 from both sides, I get negative 6. And if I subtract 2 from both sides, I get negative 2. So my x-intercepts are -6, 0, and -2, 0. Everybody okay with that? Not too bad. Again, very similar to what we've been doing, right? Let's say we have a vertex form one. Again, we'll plug 0 in for y, and we'll solve for x. Since this is a solving problem with a vertex form, I'm going to use the reverse order of operations to solve this. So I'm going to start by undoing any addition or subtraction. So I'm going to add 4 to both sides. And then I would undo any multiplication or division. There isn't any. So next thing we'll do is square root both sides. So remember, when we square root both sides of an equation, it creates a plus or minus. And the square root cancels out the squared. And lastly, we can just subtract 5 from both sides. And we could split this into 2 problems, right? -5 plus 2, and then -5 minus 2. So we get -3 and -7 as our solutions. So -3, 0, and -7, 0 are the x-intercepts. Okay. And then my last example for this, this may be an intercept form one. So again, we'll just plug 0 in for y. And then we can, since this is a multiplication problem that's equal to 0, I can just apply the 0 product property and set each of these pieces equal to 0. Now, 0 equals -5 is nonsense. That has no solution. 0 is into -5. To solve this one, I'll just subtract 3 from both sides. And this one will add 7 to both sides. So my x-intercepts are -3, 7. Or sorry, -3, 0, and 7, 0 are my x-intercepts. Okay. The next one is the axis of symmetry. And here we're going to apply a formula, and the formula is different for each form. So for standard form, we have x equals -b/2a. For intercept form, we have x equals p plus q/2. And then for vertex form, we have h. And those are important formulas, so they're things that you'll want to make sure that you remember. So I'll put a little red box around it here in the notes, so it'll be easy to find again. But you'll use those pretty regularly, so those are important ones to make sure you have some place where you can find them again. Let's do a couple of examples. So if it's standard form, I need x equals negative b over 2a. So in our case, b is 8 and a is 2. So 8 divided by 4 is 2, and then we had a negative sign still out front, so it's negative 2. So we just have x equals negative 2. Remember, this is the equation for a vertical line, right? Not like a value for x. It's not like a solution to a problem. This is going to be a vertical line. Here, we're in vertex form. So the formula I need is x equals h. So the h in this case is the opposite of this number here. So just negative 7. Done. Vertex form ones are very nice because they're fast. The last example here, we have an intercept form example. The formula there for the axis of symmetry was p plus q over 2. So p is the opposite of this one, and q is the opposite of that one. So I just get x equals negative 1. Everybody's okay there? Questions about what we've done in those examples? Okay. Excellent. And then the last situation is the vertex. So the x-coordinate is the same as the axis of symmetry. The y-coordinate we get by plugging the axis of symmetry in for x and simplifying. So I'm going to actually steal the examples that I did for the axis of symmetry so we don't have to redo finding the axis of symmetry. I'm just going to steal the problem and the result so we can just find the y-coordinate part. Is that okay with everybody? It just means a little bit less writing. So I'm just going to do my work in blue along with the previous examples. So I'm going to go up to the examples that we did under axis of symmetry, and I'm going to continue to do the second part of that for the vertex in blue, just right next to it. Okay? Hopefully it just saves everybody a little bit of writing. Okay. So now, what I'll do is I'm going to take my value for the axis of symmetry. I'm just going to plug that in for x. Now, if you hadn't already gotten the axis of symmetry, you'd have to find that using that formula, using the formulas. So negative 2 squared is 4. 8 times negative 2 is negative 16. 2 times 4 is 8. Negative 16 plus 5 is negative 11. 8 minus 11 is negative 3. So my vertex is negative 2. So the x-coordinate is the same as what we had in the axis of symmetry. And we just get the y-coordinate by plugging that x-coordinate in and simplifying. Okay. For here, the next one. So negative 7 plus 7 is 0. And 0 squared is 0. And 5 times 0 is 0. So we just get negative 10 for y. So that's negative 7, negative 10. A little tip here. In vertex form, the vertex is always h comma k. Remember where this was k. So you can shortcut through actually even plugging the h in. I mean, you can still do that and it's fine. We still get the same result. But this is one that you can do just on site. You don't have to actually do any arithmetic to find the vertex for something in vertex form. That's why we call it vertex form. Because the vertex is visible. You don't have to do anything to really get it. Okay. So again, I'm going to take my value for x that I got for the axis of symmetry and plug it in to my function. So negative 1 plus 6 is 5. Negative 1 minus 4 is negative 5. Negative 3 times 5 is negative 15. And negative 15 times negative 5 is positive 75. So our vertex is negative 1 comma 75. Any questions on any of these?
Mr. Kulik?
Yes.
So for the one that we just did within the blue, so are you just taking the x value from the previous equation and plugging it in for the x to find the y value?
Yeah, that's correct. So I'm just taking the axis of symmetry answer and plugging them in for x. Yep, that's exactly what we did.
Thank you.
Yeah, no problem. We'll do some highlighting just to make that a little bit more obvious what we did there. Okay, good. So that was actually the hard part. So that stuff is more difficult than the actual graphing piece. So to graph, what we need is the vertex, and then 2 points on each side of the vertex. And maybe we should say, oops. Let me do that. That was going to be confusing. And really I should say any 2 points on each side of the vertex. So we're going to have choice there. Okay. So we know how to find the vertex. We just went through that. So let's just dive right in and do some examples. So let's say we want to graph y equals 2x squared minus 8x plus 1. We'll start by finding the x-coordinate for the vertex. So I'm going to just write that as Vx. And remember, the x-coordinate for the vertex was the same as the way we find the axis of symmetry. Since this is standard form, I know that's going to be just negative b over 2a. So in our case, our b is negative 8, and our a is positive 2. So that gives me 8 over 4, or 2. To get the y-coordinate for the vertex, I'll call that Vy. All I'm going to do is I'm going to plug 2 in for x into my function. So just plug 2 in for x. So 2 squared is 4. 4 times 4 is 8. 8 times 2 is 16. 8 minus 16 is negative 8. And plus 1 more is negative 7. So there's my vertex, 2, negative 7. So now I'm going to make a little XY table to kind of keep things organized. And I'm going to draw mine horizontally, since I'm doing stuff on each side of the vertex. I think it's a little easier to kind of write it horizontally like that, but you could write it vertically if you wanted to, but the vertex just kind of needs to go in the middle there. And now I need 2 points that are on the left side of the vertex and 2 points that are on the right side of the vertex. To do that, I'm going to choose x's. So I want to pick 2 x's that are less than the vertex is x-coordinate, and then 2 x's that are bigger than the vertex's x-coordinate. There's no reason to be tricky or fancy or anything here. I would just pick 1 and 0 for numbers that are less than 2, and 3 and 4 for numbers that are bigger than 2. Everybody okay there? Now to find those y-coordinates, all I'm going to do is plug those numbers in for x into my function and evaluate, just like we did before. So for 0, I'm going to plug 0 in. When I do that, I get 1. And I'll plug 1 in. When I do that, I get negative 5. And then I'll plug 3 in. When I do that, I get negative 5. And then I'll plug 4 in. When I do that, I get 1. Now, if you look at the left side and the right side of that XY table that we built there, it looks pretty similar, right? Notice how the y-coordinates for 0 and 4 are the same, and the y-coordinates for 1 and 3 are the same. The question you might be thinking is, does that always happen? Do I really need to find both sides of the table? Could I just find one side and copy it down onto the other side? Well, the answer is, does that always happen? It does if you pick your x's in a certain way. So the trick is that this distance here from the vertex to those points, or to those x's, is the same. And this distance here from the vertex to those points is the same. If that's true, then their y-coordinates are going to match up and kind of be symmetric. Now, if you're confused as to what the heck does that mean, there's no real penalty for just plugging the x's in again. Sometimes they'll match up and sometimes they won't. And you might be thinking, well, is there any situation which you wouldn't choose where they wouldn't, right? If I just chose X's common sensibly, is there a case where they wouldn't match up? And my answer to you is sure, there could be. The most common situation would be like where the X coordinate for the vertex is something like 2/3, where if you picked, a number less than it as 0 and the number bigger than that as 1, they're not the same distance, right? 2/3 is 2/3 from 0, but only 1/3 to 1. Then they wouldn't match up. But if you're using like whole numbers, I just spilled my soda pop on my board. Hold on for a second. I've made a big mess. And that's why they make caps. I was just too stupid to be using one. All right. Well, hopefully that doesn't cause like an incredible problem. Okay. So that's where we left off. Right. The last thing we need to do is to just plot this thing. So I have 0, 1, 1, -5, 2, -7, 3, -5, and then 4, 1. And then we just kind of draw our graph. Looking at the time, there's not enough time really here to do examples of where we have something in vertex form and intercept form, but it works very much identically the same way. You're going to do the exact same thing. You'll just start by finding the vertex and then picking 2 points on either side of the vertex and then graphing. The last thing that I want to talk about before we go is domain and range. So the domain is easy. It's always all real numbers, which is lovely, right? We like when that happens, where it's just always the same. And then the range is 2 situations, depending on whether the parabola opens up or opens down. which again, that was decided by that value for A. If it opens up, the interval goes from the y-coordinate of the vertex to positive infinity. Or if it opens down, it's going to go from negative infinity to the y-coordinate for the vertex. So in our picture that we just drew, the domain was negative infinity to infinity. And the range, because our A is positive, is going to go from the y-coordinate in our vertex, which is negative 7, to positive infinity. Make that a little bit more brackety looking. And that basically wraps things up. I didn't want to go the full time here today, and in general, while we're digitally learning, I'm going to try to not take 80 minutes, because I think of 80 minutes watching somebody talk on a computer screen is probably pretty tough. So we spent, 5 or 6 minutes at the beginning waiting for everybody to kind of show up, and then talked for 5 or 10 minutes there, and then did about 60 minutes of stuff. And that's going to be kind of what I'm going to shoot for, is to try to keep this, the part where I'm actually doing stuff, teaching, to be about 60 minutes, and we'll spend the other 20 minutes, getting caught up on stuff, or just leaving early or starting late or whatever. So I don't want to spend that whole class time doing stuff, because I think that's awful hard for you guys, being at home and everything else. Overall, any questions about what we did in the lesson today before we break? Great. So as a reminder, if you showed up late and you didn't get a chance to check in the chat, to announce for attendance purposes, when you show up, you should type here into the chat to mark yourself as present. And then before we leave, we're going to type in bye into the chat to announce that we're checking out of class. And this is how I'm going to kind of handle the attendance every day. So as soon as you show up, you don't have to wait for me to ask for you to do that. To just type here when you show up, and that'll be good. So if you didn't get a chance to do that, and you showed up after I made that announcement at the beginning, make sure you do that before you leave. Type here and then bye. Not a big deal. The homework for today, you should do homework 10, which is the one that I asked you about earlier, which makes me a dummy. So the first 5 questions, you're just determining whether the parabola opens up or down, listing the axis of symmetry and then the vertex for each of these. And then after that, there is 3 graphing problems. Again, where in addition to a graph, you have to include the 5-point table, 2 points on either side of the vertex, just like we did in the example here. Okay, but I'm done, so you guys can leave. Remember, before you leave, to type bye on your way out. But thank you. Have a good day. We'll see you guys Friday. sufficient. That.